Hi everyone. In this session we're going to look at how to process unrolled parts using our minimal surface constructions. So for this exercise I'm going to work on a simple nodal construction like this. So it's a four-legged node that is symmetrical, and I have four sets of quad strips running along each direction. So this will basically form four symmetry groups that have three equal parts. So to show you kind of what this workflow looks like, I'll first show you another example. This is another mold that I was trying to produce. So you can see these are individual strips that are processed. Let me actually switch to the rendered mode. You can see the whole construction. So what I'm doing is basically, when these parts are unrolled, you would actually have an idea about where the joints are, where the holes are for the strips, so that when you bring together these connections, you can build a form like this. So for this tutorial, we're going to do something a bit more simpler that will require less articulation of the strips. So in the previous exercises, we basically extracted these strips using the stripper plugin, and once you have the mesh split into different parts, what I did was you can actually create some sort of an offset. This might be basically this can adjust according to the material thickness that you might be fabricating this piece. So whatever thickness you have, you can enter kind of an offset value here. I'm going to keep it at 0, so we can bypass this actually. And then once we move here, what I do is I unroll all the pieces. So you can see actually it's a very symmetrical piece, so we only have two unique pieces and symmetries of it. So then the next thing we did was we can actually spread these parts out. Now I'm going to run this on these individual strips, but imagine having a more complex form and more unique pieces, then they might you might actually have to split them into different parts. So maybe we can also look into another file that does that. So one thing I'm doing here is basically spreading out the individual parts, but then what I want to do is process these edges so that we can have joinery. And for the joints, I'm envisioning this to be manufactured out of, let's say, thick cardboard, and then we can maybe use zip ties to tie individual edges. Now, one thing that is nice about this construction is we actually, let me actually bring these parts a bit more together. One thing that is nice about this is like these edges, the lengths are shared. So if I'm basically positioning a joint along these edges, they could basically be at the same geometric location in relationship to the next piece. So what I will do is first produce these holes and the boundary so that we can actually prepare these as individual parts. So one thing that I'm not showing here is we also have to produce tags for this. So one thing you can use is kind of a dot tag. Let me see if I have one here. If you do a define text dot, for instance, you can give these strips and kind of mark where they are located inside the whole piece as well. So you can use dot tags for those. So we can actually do it, for instance, if I do the construct mesh, we can just extract one of the faces and deconstruct these faces. Let me see if we get, this gives me, maybe we do individual vertices. I mean, we can actually put them anywhere we want, but I want to just put them on the mesh strips individually. So these meshes are right now, they have 8 faces each. So what we could do is maybe find these edge vertices, I'm actually seeing a preview of these lines, which are a bit confusing. So let me hide those, and I'll bring back the form. So let's see. So we have the faces here. These are, so let's extract the first faces and then deconstruct mesh face. If we do deconstruct face, this will give us individual indices for the vertex. So if you do, for instance, list item and grab this item and the vertex, it will basically give you these sorts of rings that identify these members. And then we can put like a text dot in each of those. And the text could be just like a series of numbers, or you can give it any type of ID basically. If I do list length here, and then provided this as a tag, these will be my individual strips. So keep in mind these are running along this direction as well. That's why, like, if you don't see numbers here, it's because these strips are kind of divided. We have a total of 24. So I'm trying to keep basically IDs for these, and this should correlate with this information, right? So the strips, the geometries that we are unrolling, we also want to put a similar identification here. So these numbers kind of correlate. So what you can do is we can deconstruct brep for the unrolled surfaces, and then we can place a dot tag next to each of these. These will also be in a row, so it will go from 0 to 24 as well. So that if you want to put it manually as an information, you can also do that. Or we can find, let's say, in the list item, we can go through the edges, let's say point on curve, and if I flatten this out, so as you can see, these are the IDs for the individual strips. Okay, so we can bake this and bake these so they could be attached to individual strips. But what I want to show you is how do we actually process these strips. So let's get down here. I'm going to temporarily hide these and just work on one of these strips. So let's go to list item, and we have to come up with detail here. So let me actually show you what I have in mind. So imagine this being an edge of one of the strips. So I want to place kind of a rectangle here, and let's actually put like a rectangle, and I want, let's say, this to be the edge of one of the strips, and this is the other edge. We want to bring these two together. Maybe they're like adjacent, and then basically place a zip tie here that is going to wrap around and hold two strips to each other, right? So this is going to be kind of a loop here. And the material thickness is dependent upon, let's say, resistance. If you're using thick material, you might want to leave some sort of gap here that will work. The other detail I'm also thinking maybe we can build is a hole. So in this case, the hole could be at the midpoint along this edge, but we have to basically extend the surface to include that hole. So one way to do that would be to draw a larger circle and then clean out these edges so that you will have like a bulging geometry like this. This is actually a bit more like as an offset. But once you have the other side coming in like this, they will be just overlapping, and then that hole could be like a bolt and nut connection or something like a rivet that will hold those two pieces in place. So in this case, on the right, these holes need to overlap along the midpoint on the edge. And in the case of zip ties, you need some sort of an edge on which the zip tie can wrap, right? So that's kind of what we need to think about in terms of the connection detail. And you can come up with your own connection details as well. So I'm going to first show you how you can build the zip tie connection. So if you come here, I've isolated one of the pieces, but we're going to do this automatically to all the edges. So we will start with going to Surface tab, Analysis, and extracting the boundary representation edges. This will give us individual polyline edges of the strip that is unrolled. Then you can do a deconstruct brep, or actually we can do an explode. If you explode the curve, let's see, we get naked edge curves. That's what we want. And this will give us individual line segments. And let's look at their ordering. So if I do point on curve to the line segments and then do a point list and flatten this input. So this is the ordering of those edges. And you can see it's a bit more asymmetrical. So it doesn't start from this edge, but we can actually make it shift the list so that the ordering is changed. So I can come down here, shift it by 1 index, keep the wrapping on, and feed this in, and that will give us. Let me see. Do we have to do -1? Oh, this has to be flattened all the way here actually, so that it is processed as a single list. Okay, that's the correct order I want. So in this case, if you remember this piece, we only need connections along the side edges of these strips. We don't need a connection on the tip of these faces. So the 0.0 and the 0.9, they need to be filtered out. So there's a way we can actually do it. If you do a partition list for these resulting numbers and do a partition of 9, then this will give us 2 lists of 9, and then we can do another shift list in the negative direction. But this time, I think we have to do it in the positive direction, and then we have to make this false. So if you do this as false and then look at the point ordering, now you can see we have 0 to 7. This edge could be processed and this edge could be processed, and they are 2 separate lists. So you can also, if you want, generate different types of connections for both sides basically. Okay, once we have these edges, let's look at in one of those and how do we process the flange for this hole for the zip tie basically. So I'm going to first start by evaluating the curve. So if you do evaluate curve, let me hide the points. I'm going to reparameterize the edge and then do a midpoint evaluation. This gives me the vector, the tangent vector, and we need kind of a plane construction here so that we can place the rectangle for the zip tie. And right now, maybe we should also talk about dimensions. This piece is 36 inches, so it's roughly 3 cubic feet. And the individual strips that I unrolled, they're 2.6 inches, but they could be 10 here. So let me measure here too. So it's like 2 inches in width. It's slightly thicker here. So the zip ties, it depends on the tolerances. You might want to try how big of a gap you need to leave for the material, as well as the hole for the zip tie to pass through. But we can probably do like 0.2 inches or something like less than half an inch width for the gap. But in order to place that rectangle, we have to find a plane here that is aligned with this edge. So let me show you how you can do that. We're going to do some vector calculations. If you do vector display here, you can basically, this is our vector direction for the edge. And I want to first do a rotation, so vector rotate. So I get this vector, I want to rotate it along the z-axis, and I want to rotate it using degrees. We can do -90 to 90 and see where the rotated vector lies. So that could be, for instance, my initial plane construction. So if you do plane construct, this vector basically aligning with the edge could be our y vector. So that's my tangent. This would be my origin, and this could be my x vector. And we basically placed a construction plane along this edge. Now what I need to do is offset this slightly in this direction. So we can do point oriented. So I get the constructed plane as orientation, and I want to move it in the negative direction to x. So that will be the u direction. So if you do -0.5 to 0, and if you move it here, this will be our offset for the plane, basically. So I'm going to keep it at 0.3, and I'm going to make a copy of this initial construction plane and then move the plane origin there so that we can place a rectangle specifically on this plane that is offset. So I'm going to do rectangle, and I'm going to do construct domain. So it's going to be symmetrical in terms of dimensions. So if you plug in the same value to a and b, you can right click here and write an expression and call it -x. So this could be our, let's say, width for the hole. And this could be our depth. So right now it's slightly thick, but I'm going to make it a bit more thinner. So let's look at this. This is 0.2 inches now, and this edge should be 0.2 as well. So that's basically one of the holes. Now, how do we make it basically populated along all the edges? Well, if you go here, we were actually operating on the first edge. If you just supply the shifted list, it will actually do the same operation to all of these edges. So there's a lot of stuff happening, so I'm just going to hide some of this stuff. Let me see. So I'm going to enable it. Toggle preview off. I don't need this anymore. So we can just hide the edges, the deconstructed surface construction as well. But we actually do need this as a cut line. So I'll just bring this over here. So this is what we want to cut. We also want to cut these, right? So we can just plug them in the same container. And let me see, we have a few more points. So those are for the point visualization. If I hide it, that's kind of our part. Actually, it's very simple. And if we do the same operation in all the rest of the strips, basically our part processing for the edge connectivity will be done. So if you want to do it for the remaining pieces, here again I had another list item. So these are all my unrolled pieces. Let's actually spread them out a bit more so that they don't overlap. So I'm going to change the grid size, move this detail up. These are actually the same pieces. So you can also do like just these two and just copy it because the form is symmetrical. But in case you have like diverse pieces, you might want to do it for all the operations, all the strips basically. So one way to apply this to the remainder of the surfaces is to simply connect it here. Now it basically graphs it, and even though I kind of shifted it here, let me see if this is kind of working. So I'll just turn the points on. Seems like it kind of grabbed all the edges correctly, and that's basically it. I mean, these will be the parts that we can manufacture, and we can basically attach them to each other using zip ties along these holes. So that's kind of a simple way of adding detail. Now let me show you the other version. just in case you want to explore this sort of edge construction. So again, we're going to start with the edges. So I'll just disable this part so it's not running. And then we will do list item. Just grab the first, let me see actually what we did. So we did, we grabbed the individual naked edges. So this was exploding it. Probably I had like a list item somewhere here. So let's just work on, again, just an individual surface. We can actually do the same construction all the way up here. We don't need the plane. We just need this sort of construction. So I'll just move this down. So if I grab this and enable this portion, this will basically give me these two edges. And then I can do another list item here. And then just work on this, this edge, individual edge. We can also do it here probably. Yeah, so I can actually run it here, then we can run it at the bottom portion. So in this case, we are going to do a hole. So we can do point on curve and do a circle. So the circle size dimension is dependent on the type of bolt and nut you want to use. If you're using light material, you want the bolts and nuts to be small so that they don't put extra weight on the construction. Another option is to use rivets, but again, they're metal, so they will be adding more weight to this construction. So you might want to be a bit more precise. If you can find plastic connectors, that could also be another alternative to use for these sorts of projects. So again, this depends on the dimension of the hole. If you're using, for instance, M4 will be 4 millimeter in diameter, so that will determine our size. Here I'm using inches, but we can also convert it to millimeters, but otherwise you can do your own conversion and test for your tolerances. Now, the other thing we need to do here is I drew like an arc detail. We can also do like a curve. So essentially something like this, for instance, that can pass over the edge. That could also be nice if you want to do like a more organic boundary or overlapping joints. But I'm going to show you how you can do like a semi arc. And for that, we're going to use the arc function. And the arc would also require a base plane for construction. So this might actually come in handy here, right? We can actually use our previous construction. So if I just make a copy of this and then use this edge construction and look at this plane, that already gives me kind of a nice orientation. And this arc would also can use this plane, but it will also require a radius and an angle domain. So if you do a construction here, and then you can provide the angle domain in radians. So for instance, we have pi. Let's say we want to start from pi divided by half. So you could do this value divided by half. So we could do feed this in, hit an expression, and I can do x divided by 2. And then the other side could be this basically x times 1.5. Let's see. Oh, it's actually doing in the negative direction. So it's going in this side. So what I can do is either rotate this, rotate the plane, or you can give it a new interval. For instance, rather than going from half a pi to 1.5 pi, we can probably go from 1.5 to, let me see, interesting. So we could do 0.5. So what if this becomes 2.5 half a pi I'm wondering if I swap these two, would that actually fix it? So let me see. So I'll just make a copy of it, I guess, and then edit the expression. So this would be times 3 times 1.5. If not, we can always rotate the vector, rotate the plane as well. Well, it doesn't do it the other way, so I guess we have to draw it. Anyway, so this will, let me see, the angle is from 0 to pi. So 0 is x basically. So our target is supposed to be, I guess we could do negative. Let's see. Negative x divided by 2. And if I do x divided by 2. Yeah, that actually fixed it. So negative 92 plus 90. That will be basically our arc. And then we can do a radius here. So it's like a small flange like this. But one thing I need to consider is I need to connect the endpoint of this arc to the endpoint of the line, right? So that's very important, so that we are also adjusting the edge. So if you do endpoints, grab this line, same thing here for the arc, and then you want to draw two new lines. So the starting point connects to the starting point, and the endpoint connects to the endpoint. And then we just need to put all of these into one line, and then you can do join curves basically. So this becomes like a singular construction. So I'll just turn this off. Let's see, that's now my new edge, and this will be the hole basically, right? So those are the two things that we need that is processed. Let's go back here. I'm going to plug all the actually before all the surfaces, we need to do this to all the edges, right? So these are the edges. So if I basically do curve here like a container, supply this in, if I replace this all, these flanges are basically processed now. And let's see. So we might want to just also bake these edges in this case, so that we can move the pieces around. So where are those edges? Well, we're actually filtering them out with the shift list. So if I did list item and grab those back, brought them here. So these are the joined edges, but I can also plug these in here, holding shift. And let's see, well, they need to be merged in the same lists. So let's see, let's do simplify here, another simplify here, merge them in. Now they're joined. If I put them in here, they should give me like basically two edges. If you bake, it should give you kind of a nice boundary. And we can also bake the holes. So if you bake the holes, bake the edges, that'll basically give you the part to cut. So these will be the holes, which are midpoints of the edges, and we needed the flanges so that we can extend the material, so that we can place those holes in those positions, right? So the other edge will come in here, so I can just show you if we did this to all the other parts. So let's bake them and bake the holes. So the nice thing about this one is everything is parametric, so we can adjust the tolerances, the details, and you can see even though the parts are not kind of touching, what needs to happen when you fabricate these is once you start attaching these holes, as let's say for instance this part, I'll just group it. If I put this here, they will basically start forming this relationship, right? And then they will be aligning here, let's say along this edge. You can see that joint works. And this hole would actually has to meet this hole here. So these will start folding in 3 dimensions to acquire this shape, right? So once you start folding these parts, they will these holes will start aligning actually, and it'll be quite surprising, but that's how you can put this together as detail. Okay, so that's basically it, how you can process these edges, flanges. Let me see if I can also try another form. I had a few more files here, so let me see. Let's look up, for instance, I had this guy here. We can also maybe look at this one, like a gyroid construction, or even this too. This could work, like the bat wing. Let's actually bring in this. I'm just going to, okay, it's super small. So let's increase the size of it to 36 inches. So that's costless surface. So let's see what will happen to it if we follow the same protocol. So I baked these, but I'm just going to delete these strips. So let's try putting this mesh in. All right, so you see we get a lot more organic forms, actually, a lot more different shapes. So I'm just going to hide it, go to shaded view. So let's look at these strips. So I'm curious to see. And we can visualize probably the mesh boundaries as well. But let's bake this. Okay, so it's giving me rings in this direction, and we have too many of those, and the strips are kind of thin. But it kind of depends on how the surface is discretized. So if I change this, let's keep this true, but let's do it in the U direction. That will probably divide it up in different ways. Okay, now we have basically these sorts of arcs running, which might be a bit better actually. Yes, so it's still giving me these sorts of weird curves. Maybe we can process them in. But if you have shapes like this, you still need to process these edges. So I'm seeing, for instance, maybe the script needs to be adjusted because of the shifting functions. Like if you remember, we did partitions here, right? So probably these partitions are not working because we have more edges. So for instance, when I get the strips, some of them have 34, some of them have 60, so they might have to be processed separately, essentially. So in order to do that, you might want to just filter them out. For instance, let's say we are filtering strips with longer edges. You then may want to just, let's actually do it here. If you do list length, that will give you the length or the number of edges per piece. So a lot of them have 34. There are some that are 24. Some of them have 27. So if you want to just place the same detail, then you have to basically clean it up, right? So you might have to do some manual operation, but the scripts can help you build these sorts of detailing along the boundaries. So not maybe everything can be automated here, but at least if you process all the edges, then you can basically simplify some of them, or choose some of them. Or maybe you can bake the individual strips and put the same length ones into one code and then adjust it and process these as well, because you won't be able to fit these in to the laser bed, so they have to be divided up into manageable chunks. So for instance, a strip with 60 faces, it might have to be divided into like faces of 20, right? So this is maybe like three different strips in that case. Yeah, so that's essentially it. So this might require more work because it apparently has more edges too. Let's actually look one more form. Let's go back here. Let's see, was it this one? Okay, so let's grab it. So I don't have the relaxation for this one, but we can try doing the gyroid. So again, it's relatively small. I'm just going to make it 36. Okay, so that's the shape. So let's actually just, I'll do like a simple Catmull-Clark subdivision. So I'll just bypass it here. So Catmull-Clark. And do a level 2. And feed this in. Oh, we didn't actually do the stripping. So let's do that first. Okay, so let's go back here and feed this in. Hide the original form. Well, it's not joined, so let's do, okay, join meshes and weld. All right, so I'm just looking at the topology of it. Essentially, we have 4 quads running in both directions, and if you bake these, let's see, it gives me basically strips running in this direction, but some of them are very long. And you can also look at the unrolled strips, right? So some of them are very short. So we have like 2, 4, 8 joints on the sides, but these are very long. So they have to be probably divided up into 16 or 8 face long strips. So this will require some sort of pre-processing before you cut these, because they won't also fit into the laser bed. So you need to divide this up into chunks. But essentially all this workflow can be applied to mesh geometries, and you can develop some sort of edge detail. And hopefully you can just automate the whole process and see what you can generate as the model. And I hope this is helpful. But in the next one, we're going to do look at some sort of openness functions on how to organize these into sheets, and then you will basically have your fabrication parts ready. And I'll see you in that video.